Today's topic's difference between PT100 and PT1000 RTD sensors. Have you ever seen sensors named PT100 or PT1000 and wondered what's the real difference between them? They look almost the same. Both are platinum RTDs. Both measure temperature, yet one small number changes everything. Today, we'll break it down in the simplest way. No complicated equations, just pure understanding that makes sense. Quick recap. What is an RTD? Before we jump to PT100 versus PT1000, let's take a quick moment to recall what an RTD actually is. RTD stands for Resistance Temperature Detector. It works on a simple principle. As temperature increases, the resistance of a metal, usually platinum, also increases. That resistance is measured and converted into temperature. And platinum is used because it's super stable, accurate, and corrosion resistant, perfect for precision sensing. What PT100 and PT1000 mean? Alright, so here's the key. PT means the element inside is made of platinum. The number 100 or 1000 tells us the resistance of that sensor at 0 degrees Celsius. So, a PT100 has a resistance of 100 ohms at 0 degrees Celsius. A PT1000 has a resistance of 1000 ohms at 0 degrees Celsius. That's the main difference. PT1000 simply has 10 times higher resistance than PT100 at the same temperature. Working principle, same but slightly different behavior. Both sensors work exactly the same way. As the temperature rises, their resistance increases. But because PT1000 has higher base resistance, the change in resistance per degree Celsius is also higher. That means it can detect smaller temperature changes with more noticeable resistance variation, giving slightly better sensitivity in some cases. Wiring and signal accuracy. Now here's something important: wiring. With PT100, the resistance of the connecting wires can cause small errors, especially in long cable runs. That's why PT100 sensors often use 3-wire or 4-wire configurations to cancel out the lead wire resistance. PT1000, on the other hand, has 10 times higher base resistance, so the effect of wire resistance becomes much smaller. This means PT1000 can give accurate readings even with a simple 2-wire connection, making it ideal for smaller or remote installations. Accuracy and range. Both PT100 and PT1000 are very accurate, but PT100 is usually considered the industrial standard for high-precision applications. It's used in systems where calibration, repeatability, and long-term stability are critical. PT1000, meanwhile, is popular in HVAC, environmental monitoring, and electronics because it's easier to connect and often cheaper to implement. So, if you need high precision, choose PT100. If you need easy wiring and cost-effective solutions, PT1000 is your friend. Temperature range. Both sensors can typically measure temperatures from -200 degrees Celsius up to +600 degrees Celsius, depending on their construction. So there's no big difference in range, it's more about the signal quality and wiring style. Real-life example. Let's understand with an example. In a power plant or refinery, engineers prefer PT100 sensors because the system uses long cables, 4-wire setups, and demands precise calibration. But in a greenhouse or air conditioning system, a PT1000 is ideal. It's simple, requires less wiring, and gives accurate readings without much complexity. Same family, different strengths. Summary table. So, in the end, both PT100 and PT1000 are like siblings, sharing the same DNA, just built for different roles. PT100 stands for industrial precision and trust, while PT1000 stands for simplicity and smart performance. And that's the beauty of engineering. Even small numbers like 100 or 1000 can make a big difference in how we measure our worth. If you learned something new today, make sure to like this video, subscribe for more real engineering explanations, and share it with your friends who love learning technology in a simple and human way. Because knowledge feels best when it's shared.